SciShow Space is supported by Brilliant.org. It might not always seem like it, but there's a lot going on around us in the universe. Stars are forming, planets are being born, galaxies are being ripped apart. You name it, and it's probably happening somewhere. But in the middle of all this action lie ancient relics of a universe long gone. They are red nuggets, and they're galaxies that have done the seemingly impossible, survived billions of years of cosmic evolution without a scratch. Finding one is like discovering a message in a bottle, a time capsule from the early universe delivered to our doorstep. They get their name because they're as valuable as gold, but red in color. And if we can understand their secrets, they have a lot to teach us. Astronomers today recognize two main types of galaxies: spiral and elliptical. Spiral galaxies are probably what popped into your mind when we started talking about galaxies. They're pretty flat, with long, sweeping arms, like the Milky Way. They're also full of younger, hotter stars, so their light tends to be relatively blue. Elliptical galaxies, on the other hand, are full of older stars, so they tend to be redder and cooler. They're also much less ordered than spirals, with blobby, uniform shapes. Astronomers have spent much of the last century trying to sort out how galaxies end up in these two basic categories. It's now generally accepted that spirals form first, and then ellipticals are born from the collision of two or more galaxies. This helps explain why spirals are full of younger stars and ellipticals older ones. It also makes sense why the collision-born elliptical galaxies are so messy in appearance. But with all this stuff smashing together, it's hard to know how lives of galaxies are supposed to play out, in a sense. If the universe were really a more peaceful place, what would things look like? That's where red nuggets come in. These objects were first detected by the Hubble Space Telescope in 2005, and in 2013, astronomers found more of them much closer to home, like only a few 100 million light years away versus billions. These galaxies are both massive and compact, meaning they have a lot of stuff inside of them, but they don't take up much space. Some can have more mass than 10 Milky Ways, but also be 10 times smaller than our galaxy. But what's arguably even cooler about red nuggets is that, from what we can tell, they appear to be the ancient remnants of the first generation of elliptical galaxies. Also, they're not just ancient. Those nearby red nuggets specifically also appear to have avoided collisions since their formation, some for more than 10 billion years. I mean, they've been drifting alone through space for longer than we can really wrap our heads around. Scientists are still trying to piece together what all this can teach us about modern galaxies, especially the elliptical ones. But for now, there is one red nugget mystery we think we've already solved. See, one thing that's really notable about these objects in general is how dead they are. Astronomers call a galaxy dead if it stopped forming new stars. And from what we can tell, even the youngest red nuggets don't seem to be making anything new. In fact, that's why astronomers call them red nuggets. Without any new blue stars to balance things out, the galaxy gets redder and redder as everything ages. The good news is, a clue as to why may be hiding in plain sight: an overactive supermassive black hole. Scientists believe all galaxies may have supermassive black holes at their centers, like ours does. The one the Milky Way hosts weighs in at 4 million times the mass of the Sun, which is kind of a lot. But some of the largest black holes we've ever seen are at the center of red nuggets. The biggest are more than 1,000 times more massive than the one in our galaxy. So it could be a simple explanation: the huge black holes are swallowing up all the material that otherwise would create new stars. Well, not really that simple. NASA's Chandra X-ray Observatory has shown a bunch of extra heat at the center of one nearby red nugget, heat which probably comes from the black hole. The heat would have made gas in the galaxy too hot to easily collapse down and form new stars, a process astronomers call quenching. Then, over time, that gas could have fallen into the black hole, growing it to such massive proportions. This process isn't unique to red nuggets, but they do prove it's a mechanism that can work even after billions of years of isolation from the rest of the universe. And the fact that we can figure that out at all is pretty impressive. Now, we just need to investigate other mysteries, like what these ancient galaxies can tell us about the formation of the modern, massive elliptical galaxies. But right now, it's okay just to stop and be amazed. It's a violent universe out there, and we finally started to find the ultimate survivors. And speaking of finding things, scientists make all these discoveries using the scientific method. And you can learn all about that at Brilliant.org. I've talked a little before about the scientific process course on Brilliant and how it walks you through the process of making observations and hypotheses. Well, once you've made those observations, asked questions, and hypothesized, as a scientist, you need an experiment to investigate your hypothesis further. And a lot of careful thought needs to go into designing an experiment. In this quiz, Experimental Design, you need to think through what questions you're trying to answer. You need to consider controls and variables, and at some point, you probably need to reconsider your original question. It's an entertaining and helpful way to more deeply understand the scientific process. The world is complex, and one thing I like about Brilliant is that their lessons don't shy away from that, but they do keep it fun. And right now, Brilliant is offering 20% off their annual premium subscription to the first 200 SciShow Space viewers to sign up at brilliant.org/SciShowSpace. So check it out. And if you take the experimental design quiz, let me know how you do in the comments. Like good scientists, we can compare our results.